Today I will be sharing to you about intercepts of rational functions. What is an intercept? And how do you determine the intercepts of rational functions? To answer those questions, stay with me in this lesson. Let us first look at the definition of the intercepts. Intercepts are x or y coordinates of the points at which a graph crosses the x-axis or y-axis respectively. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. In the graph below, we can see that the graph crosses the y-axis at point -4. Therefore, our y-intercept is -4. The x-intercept is the x-coordinate of the point where the graph crosses the x-axis. In this particular graph, at what point does the graph crosses the x-axis? That's right, it's -8. Therefore, -8 is the x-intercept. It is easy to determine the x and y-intercepts when there are graphs. But what about if there are no graphs, only given functions? Now, this is the rule. To find the y-intercept, substitute 0 for x and solve for y or f of x. Or in other words, evaluate the function at 0. To find the x-intercept, substitute 0 for y and then solve for x. Let's have some examples. Find the intercepts of the following rational functions. We have a, b, and c. Let's do this one by one. For example A, our function is quantity x plus 9 over quantity x minus 3. To solve for the y-intercept, first, we substitute 0 for x, or we try to evaluate the function at 0. Then simplifying, we have 9 over -3. Therefore, the y-intercept is -3. For x-intercept, first we substitute 0 for y or f of x and then we solve for x. Next step is to multiply both sides by x minus 3 since x minus 3 is the least common denominator or LCD. Remember the rules in solving rational equations. Simplifying, we have x equals -9. Therefore, the x-intercept is -9. Let's proceed to example B. We have the function f of x equals x squared plus 3x plus 2 over quantity x squared minus 5x plus 6. For y-intercept, again, we substitute 0 for x. Simplifying, we have 2 6 or 1/3. Therefore, the y-intercept is 1/3. For x-intercept, again, we substitute 0 for y or f of x and then we solve for x. Multiplying both sides by the LCD, which is x squared minus 5x plus 6, we have this line 0 equals x squared plus 3x plus 2. Factoring x squared plus 3x plus 2 gives us the quantity x plus 2 times quantity x plus 1. Applying the zero property, we have two values of x, and therefore the x-intercepts are -2 and -1. Let's proceed with our last example. f of x equals quantity x squared plus 4 over quantity x squared minus 1. For y-intercept, we evaluate the function at 0. Simplifying, we have 4 over -1. Therefore, the y-intercept is -4. For the x-intercept, again, we substitute 0 for y or f of x and then solve for x. Multiplying both sides by the LCD, we have the remaining in our equation, which is 0 equals x squared plus 4. We transpose 4 to the other side of the equation, and that leads us to -4 equals x squared. Finding the square root of -4 is already imaginary. Therefore, there is no solution for x squared plus 4 equals 0. Hence, there is no x-intercept. You can actually check the x and y-intercepts of the functions given by graphing them. Using a graphing software, you can see where the graph crosses the x or the y-axis. I hope you learned something from today's discussion. See you in the next lesson.